Where's the next lesson? That's your lesson. Me too. Maybe we should. You're good up there. How you doing? Good.
Okay, some of this you may need your calculator for, so I do want to go through each of these problems with you. So let's look at page 7. Okay, so if g is differentiable function, so that just means a smooth curve. Slope exists at every point, such that g of x is less than 0. So we know g is a negative value. And f prime is x squared minus 4 times g of x. Which of the following is true? So it's asking information about relative max, relative min. So why don't we just create a slope sign line and gather that information, right? Because wherever f prime is 0 is where our critical points will be. So we'll go through the first derivative test. We'll set f prime equal to 0. We don't have to worry about g of x because we know g is just going to be some negative number. Just have to be able to factor this, right? X squared minus 4, we can factor that, get x plus 2 and x minus 2 to show up. And then we find our critical points, -2 and 2. And then we create our slope sign line. Okay, we choose values in each subinterval to test. I'll just test -3. I can test 0, and I can test 3. Okay, they all get inserted into f prime. So I get negative, negative, and then we know g is always what? Negative as well, right? So 3 negatives gives me negative. I know that this interval, my graph is decreasing. I plug 0, positive, negative, negative. So 2 negatives makes positive. Plug 3 in, positive, positive, negative. 1 negative makes negative. So now that we have the sign line in front of us, it's a lot easier to eliminate the wrong choices and pick the right one. So f has a relative max at x equals -2. Is that true? False, right? Relative minimum at x equals -2, relative max at x equals 2. This looks to be true. B looks like the right answer. Let's go down the other options. So f has a relative minima. So minima, maxima, all that means is these are just plural. So that means there's 2 minimums at -2 and 2, but we don't see that's the case, right? So that's not true. And then it cannot be determined, but we can, right? F prime sign line. Okay, number 10, f double prime. Find points of inflection. We know points of inflection is where the second derivative is equal to 0, and there's a change in sign. So we have to go through our concavity sign line for the second derivative function. So yeah, go ahead and try that. It's going to feel virtually the same thing as number 9, except instead of setting f prime equal to 0, we're setting f double prime equal to 0. Okay. All right, so try that and see if you're able to come to the conclusion that we did for 9, similar steps. So these are all my test points on my second derivative sign line. The nice thing about having that squared here is that we know we don't have to test that parentheses because we know anything squared is positive. We know that the sign is going to be purely dependent on the first two terms here. So -2 for x, that's negative times negative, that's positive. We know squared is always positive. -1/2, negative times positive is negative. Log 1n, positive times positive is positive. Log 3n, positive, positive. Oh, sorry, my bad. This should be what? This is not slope. This is what?
Yeah.
Concavity, yeah. So I shouldn't be using arrows there. I should be using those parabolas to indicate we're at the second derivative level, not the first derivative level. So are all these points of inflections? Just what?
-1.
Yeah. I would say that sometimes the tendency that students experience with a problem like this is they would find the critical points and then they would say, okay, I found my critical points, so there's my answer, and they would forget to do the sign line. So just be careful, right? That the sign line is testing if the candidates are actually valid, because these are critical points, but they're not quite confirmed to be points of inflection until we look to see if there's a change in sign. So at 2, there is no change in sign. So not a point of inflection.
It's my -1 and 0.
Right, no, only -1 and 0. But I just want to point out that, you know, when you take your multiple choice test exam, you know, these test writers are anticipating what mistakes students can make, and they will make sure to include that as an answer choice. So, you know, just be aware of that. You know, just because you see your answer choice in the selection doesn't mean that it's going to be the right answer. Sometimes it could be a distractor. So, okay, number 11. The polynomial function f has selected values of its second derivative given in the table. Which of the following statements must be true? So where do you see a potential critical point if we're looking at f double prime? At 1, right? So if I create a second derivative sign line, because there's a critical point there, right? Because second derivative is 0. What do you see to the left of 1? Positive or negative? Positive. Okay. What do you see to the right of 1? Negative. So what could be your conclusion? What could be happening at 1? Point inflection. But this is tricky part is it guaranteed that we're going to have a point of inflection at 1? Does the graph have to change signs at 1? It doesn't have to, right? It could hit 0, stay positive for a little bit longer, and then switch to negative between 1 and 2, right? And so because of there's this gap of information here, we can't say for certain. I mean, it's possible that there's a change in concavity right at 1 or change in sign right at 1, but because of the gap here between 1 and 2, we have to take that into account and say that, okay, we know it's going to change signs. We know there's going to be a point of inflection somewhere between 0 and 2 because there's a change in sign 5 to -7. But does it have to occur at 1? It doesn't have to, right? It could occur a little bit later, that change in sign. So that's the tricky part. They're trying to see if you can fall for a point of inflection that x equals 1, because of the vagueness and the lack of data, we can only say that there is a change in concavity between 0 and 2, but not guaranteed to happen right at 1. Okay, number 12. Let g be the function given by g of x equals x squared e to the kx, where k is a constant. Again, treat k like a number, like a 3 or a 5 or 6. Don't get thrown off by that k. It's like, oh, I've never seen that before. How do I do it? Just pretend like it's a number and then just treat it like a number. Okay. For what value of k does the graph have critical point? So critical point, how do we find critical point? We first have to find what? Derivative, right? And then we set the derivative equal to 0. So that's our strategy there. We find the derivative, set equal to 0, and then we can worry about solving for k. Now, if I want to find the derivative, what else is involved? Product rule, right? And then, okay, so let's see if we can handle. Let's see if we can get all the way down to the derivative, set equal to 0, and then replace x equals with 2/3, and then we should be able to solve for k. Okay, f prime. It's f prime. Nice. G function, no changes. Back to f. Squared. Okay. What's the derivative of e to the kx? Yeah, e to the u times u prime, right? That's the derivative for e to the u. So e to the kx times k equal to 0. Set f g prime equal to 0. Replace every x with 2/3, and then it becomes just an algebraic equation that we can just solve for k.
Does this one get your calculator?
This one is non-calculator. But even if we had a calculator, it wouldn't do too much help. We still have to do all the algebra associated with it. Sorry, k, not x. K, x has been replaced. Okay, I'm gonna set them equal to each other and see if things will cancel out. I have a bunch of k's in the way. Hopefully that some of these will cancel out here. So I'm gonna subtract this over to the other side here. Now, what do you notice here? What's something that we can do to make the equation easier to solve? Yeah, we can just divide that e to the 2/3 k from both sides, and that can just easily go away. We still have that k coefficient in front, so now it becomes a lot easier, right? 4/9 k equals 4/3. If I divide by 4/9, it's the same thing as multiplying by the reciprocal. The reciprocal is 9/4. So 36/12. I can also cancel the 4s out. 9/3 is just 3. Oh, sorry. When I subtracted that 4/3 over, I should have carried a negative along with it. I'm changing the sign there. Okay, now this one is the calculator question. Number 13. Number 13 says, let f be the function with the first derivative, f prime. Well, what value does the graph have a max value on the closed interval from 0 to 2? So, or where does the graph of f have a max value? So we're not looking for a max value of f prime, we're looking for a max value of f. But we can still graph f prime and then see if we can interpret where our relative max will be. So in your graph here, we're going to do sine of x cubed. Make sure you're always in radian mode. So y equals sine x cubed. If I do zoom 6, I can get a graph going, but this is probably showing more than I need to see. So I can just put a box around 0 and 2 because I know that I'm only looking at the interval from 0 to 2. So you can either go back to your window and just play with those numbers, make it 0 to 2, and then y min and y max from like maybe -3 to 3. Or if you want to just draw a box, you can. You can do second. You can just do zoom 1, and just put a box around that interval from 0 to 2. All right, my y max is at 1.9. Let me just change it to like 2.5, just so I can see around on the edge a bit. Okay, so this is my derivative graph. So I want to just sketch my derivative graph and understand that, we can't look at this and say, okay, my max is here because this is not the original graph here. This is the f prime. So if we're looking at the f prime graph, I interpret accordingly here. Above the x-axis is a positive slope. Below the x-axis is negative slope. On the x-axis is slope 0. So our critical point is at whatever this intercept is. So let's find that x-intercept. Second trace 0. Left bound. And pick a point to the left, to the right of the x-intercept. Hit enter again. And I get 1.464. Now there's another x-intercept here, but okay, let's go ahead and find that because that's also something that we can use. Second trace 0. Now I'm going to pick a point on the left of the second x-intercept, hit enter, and then pick a point on the right side of the second x-intercept. I get 1.84, 1.84. Now we see to the left of 1.464, our first x-intercept, it's above the x-axis, so that means the original graph is rising. Between 1.464 and 1.84, the graph is falling, and then it's going to rise again. So based off of that, we can tell that our maximum is going to be here and not here, right? It would make sense for a relative minimum to be the highest point. So the highest point is going to be at 1.465, rounded to 1.465. Even though this is what the f prime graph is showing, the arrows are indicating this is what the actual graph is looking like. Okay, let's look at 14. Okay, 14, it says the graph of e to the tangent x minus 2 crosses the x-axis at one point on the interval from 0 to 1. What is the slope of the graph at this point? So what we can do is we can find, first off, where across the x-axis. And then from there, we can find the slope of this graph at that point. First things first, we can graph it and look to see where it actually crosses the x-axis. We need that information from the calculator. So e to the 10x minus 2. Zoom 6 again. I like to I need an x-intercept between 0 and 1. So looks like it's somewhere here. I can either zoom in or I can just go ahead and do second trace 0. I think I can probably do it without having to zoom in too far. So I'm picking a point to the left of my x-intercept, enter. And I'm picking a point to the right of my x-intercept, hit enter again, hit enter a third time. I get 0.616. Now, it's not asking for the actual point, it's asking for the slope. So we know the x value is 0.606, but that's not the right answer, right? Because we know the x-intercept, but that's not the slope. To find the slope, I'm going to find the derivative and then plug this into the derivative. But we can make our calculator do that for us because you have your Math 8 feature. So if you do Math 8, you can ask the calculator to evaluate the derivative of a function at a point. So all this can just be done in the calculator. So we'll do e over dx, e to the tangent of x, and then plug in 0.606. Oh, sorry. Thank you. Minus 2. Okay, so we plug in the full original function, make the calculator find the derivative. Now, you could find this by hand. You could do it e to the u times u prime and then plug in on your own, but we can make the calculator do it for us here. So that's the slope. That's the slope of the graph at this point, 2.959. This is the right answer. A16, the first derivative is given. What interval is f increasing? Again, this is one of those where we can use the graph to get our f prime to show. And then we can look to interpret our f prime graph, right? So again, we have to be comfortable with plugging the calculator, finding the x-intercept, and then interpreting our derivative graph. So again, I'm going to y1, I'm going to type in sine of x cubed minus x.
Question 15 is just good.
Oh yeah, so we're done with 15. Now we're moving on to 16. Is that what you're asking?
Oh, yeah. Use this question 14 and 16.
Oh, sorry. Yeah, sorry. That's a miss typo on my part. Yeah, so no 15.
Okay.
Okay, sine of x cubed minus x. We'll do zoom 6 here. Well, it's actually again from 0 to 2, but so you can either do zoom 6 or you can just have the graph go from like -1 to 3, just so you can see around the edges. I would like to see a little bit closer to what's going on here. So I can do a zoom box or I can adjust my window so I can just see maybe from like -2 to 2, just so I don't have to look at all that space above and below my graph here. Okay, so here's my graph here. I want to just sketch what this graph could look like. Now I made it, this is what I had. I went through my x-intercept process as well. And I did second trace 0. I found this point, I found this point. I don't care about this at x-intercept because I only care about what's between 0 and 2. And then we know that this is the derivative graph here, so we can't say, oh, it's increasing from here to here. Remember, this is f prime. So we can label accordingly. Above the x-axis is positive slope, below is negative slope. So we're starting negative slope, positive slope, negative slope. So if we translate that into from the arrows here, wherever it's increasing is going to be wherever it's above the x-axis. So that's the interval we're looking for. Okay. Again, I know we're maybe tempted to want to say that, oh, it's increasing here, but we have to keep reminding ourselves this is not the original graph here. We have to interpret this derivative graph and know that the actual graph is not rising until this interval here from 1 to 1.691.
Was A like right before?
I'm sorry.
Is point A on the graph right before the line? It's like the opposites.
Point A. You mean option choice A? What do you mean?
Oh, like you know, there's a dirt point all the way to the right. Oh, it's 2. Sorry.
Yeah, this one is
Times A.
2. Yeah, that's 2. Yeah, that's 2. Okay, number 16. Again, yeah, so typically if you're given if you're asked to graph something, typically what they like to do is they like to ask you to graph the f prime and to be able to interpret it. So it's not going to be as clear as, okay, here's the function, graph it, where's the max and min? There's got to be some calculus feature to it. And so usually it's graphing the f prime and then interpreting that f prime graph. So 16, same way. You're looking at the f prime graph. Your relative max is going to be an x-intercept where the slope changes from a positive to a negative, where it goes from above the x-axis to below the x-axis. So we can test that out and see if we're able to get that.
When I graphed it, I didn't get it to look like that.
Okay. Let me see.
I guess maybe you, never mind. I think you zoomed in a lot. Well, no. Yeah, like that's normal, right? You just zoomed in.
Yeah. Mine is just zoomed in. Let me just double check.
How do you know the interval though?
You don't know what the interval is, but if you look at your answer choices, all your answer choices between -2 and 1. So that's my indication. I know I can set my interval between those 5 points because I don't have to worry about anything else. Yeah. So yeah, your answer choices sometimes can help give you an idea of how to set your window. Okay, 17 again is asking you to graph f prime. And then now if you're looking at the f prime graph, how do we find points of inflection? Where do we look for if we're looking at f prime graph? We're looking for points of inflection. We look at the what? X and mins, yeah. So the peaks and valleys of your f prime graph is going to show you where your POI is. So here's my f prime. Again, they tell you the interval. So -2 to 2, you can set your window, x and y from -2 to 2, and then I didn't have to look to my x-intercept anymore. I just have to look to see where my peaks and valleys are. I have 5 peaks and valleys, right? 1, 2, 3, 4, 5. Number 18. Particle moves along the x-axis so that at time t greater than 0, its velocity is given by v of t. So we have v of t here. What is the acceleration? Acceleration, you know, is the first derivative of velocity. So we just do v prime of 4. And again, math 8 will do that for us, right? Math 8 and deriv. We plug in our velocity function. We don't do any calculus by hand. We can make the calculator do it for us. So math 8 and deriv, and then v prime of 4. So plug in your velocity function, plug in 4. It'll get to the acceleration and plug 4 in for you, get you that 1.663.
Are you from 7, or it's 16 years at 17, like above? What do you for that?
Oh, right, above it. That x-intercept is at 0.350. The last 2 pages of first semester topics is on page 13 and 14. We'll revisit 9 through 12 on Wednesday after we get past the first semester topic quiz or test. So let's look at page 13. So this is one of those derivative inverse at a point. Remember that process, kind of going through our chart to fill in appropriate information here. So we know that between a function and its inverse, the order pairs will always be flip-flopped. And then at their corresponding points, the slopes will be reciprocals of each other. So I'm going to go ahead and create my chart for my problem here. I'm looking for the derivative of f inverse at 2. So that goes in that bottom corner here. I know that 2 is the x value of my inverse. But 2 is the what of my function. The y value, right? We know inverse and function will always have the x and y values flip-flopped. So the idea is if I can figure out what the x value is, then from here I can find f prime of 1, and I can from there fill in the slope. So we're not touching anything on the inverse side. We're doing everything on the function side, and then using that information to conclude what's happening on the inverse side of things. So I know that 2 is the y value, so I don't want to insert 2 in for the x. 2 is the y value of my function. Right. I don't know what this piece is. Right. I don't know what the x value is. So 2 is equal to x cubed minus x plus 2. Normally we'll have to go through guess and check, but in this case, it looks like the 2's can cancel out. I'm just left with 0 is equal to x cubed minus x. You can factor the x out. So my x can either be 0, -1, or 1. Now, normally we don't have to worry about all the 3 options here, but in this case, let's just go ahead and find f prime of all those values and see which one of our answer choices show up. So that means if I can find f prime at these points, I can flip it and see which one actually shows up. So I'm going to find f prime. What's the derivative of f?
3x.
I'm going to just test all these points here. F prime of 0 is going to be -1. F prime of -1 is going to be 2. And f prime of 1 is going to also be 2. So if I flip -1, I get -1. I don't see that option show up. If I flip 2, I get 1/2. That option is there. If I flip 2, I also get 1/2. So if this is 2, I get 1/2. That's what you see there. Numbers 2, 3, and 4 are all going along the same vein here, so you guys can kind of practice that process. Let me do one of the linear approximation here. So linear approximation, all this is we find the order pair, we find the slope, we build our tangent equation, and in our final step, we worry about that decimal here. So let's just focus on tangent line equation. Let's just find our order pair. So our point okay, if I plug 0 in for x, I get 1 minus 0, which is 1. Square root of 1 is 1. If I want to find my slope, I have to get to my derivative. To get to my derivative, I got to go through what rule here? Chain rule, yeah. So let's find f prime. Bring the 1/2 down. plug in 0. Sine of 0 is still 0. Cosine of 0 is 1. This is going to just get me slope of 1/2. Okay, I have my ordered pair. I have my slope, point slope form. And then finally, I can, once I get my point slope form going, I can plug in that negative 0.1 as my decimal. And then once I have my tangent line equation, my decimal can just go in for my x. And I think the rest of the page is also dealing with that as well. Okay, so your homework over the weekend is just to finish up pages 13 and 14. We'll skip 9 through 12 for now. On Monday, we will chip away at the review for Monday for Tuesday's test, which is 15 through 18. Okay, so if I can come around and just check your pages 5 through 8. Okay, quick, guys incoming, get your phones. We're gonna veer off from the calendar a little bit, so I'll send out a reminder this weekend, page 13 and 14. Also, next week, we're on EOC schedule. Tuesday is gonna be a full regular bell schedule, but Monday, Wednesday, Thursday, Friday are all late starts. So look at the website for the calendar. But it's going to be, we're still going to have class, but Monday and Thursday will be short, really short, like maybe like 20, 25 minutes, but Wednesday and Friday will be a little longer. Those will be like 35 minutes-ish. But it also depends on, what time, because if things get dragged out, then they'll send out a new bell schedule for any days that gets extended, or any of the EOCs that gets extended. Okay. Okay, so again, your Tuesday test will only be 8 problems from first semester topics, so the ones that we've done so far.